Hi guys, so what we talked about this morning, I'm going to post two videos here. One is going to go over 2 pages and the other one's going to go over the other 2 pages. So if you would like to, you can go ahead and pause this video, get your packet out, and open up to day 4 because we're going to start there. Hopefully you have it. If not, take a second, pause this so you don't miss anything. Day 4 is actually pretty simple. This is just finding any equivalent fraction by multiplying by a constant. This is getting us in the habit of, to find an equivalent fraction, it has to be a constant. Constant meaning that this second number here has to equal 1. Okay, so it doesn't have to be a 1. If you put multiply by anything by 1, you're going to get the exact same number. But we do know that 2 over 2, 2 out of my 2 pieces, that is a whole piece right there. Okay, so we know that 2 out of 2, I'm trying to make it so you guys can really see it. We know that 2 over 2 is 1. Sometimes I like to draw it like this because when you multiply anything by 1, nothing changes, okay? It's the same number. So if nothing's changing here, that means my fraction, the numbers might change, but the value is the same. And if I was to draw an example, my first one would be cut into 3 pieces because it's in thirds, so I would make 3 pieces. My second fraction, when I'm ending at 4/6, I'm going to make it the same starting size. But I would break it up into 6s. The first one's 2/3. My next one is 4, 1, 2, 3, 4. They are the same fraction. Okay, they equal the exact same thing if you were to use your fraction strips with it, which we went over a couple weeks ago. So for all of these, you can pick any number you want. You could pick 1,000,000 if you really wanted to and get this huge, crazy fraction. You don't really need to, but if you want to get a little creative with them, you could always use the same number on all of these. My suggestion is to start using different numbers to try and find different things. So let's do number 2 together. Okay? We're starting at 4/5. I need to multiply by any constant, meaning any number that equals 1, meaning the top and the bottom have to be the exact same number. You could pick any number you wanted. So if we were in class, I would have someone tell me a number, but I'm going to pick a number. I'm going to pick number 4. If I put 4 on the top, that means I have to put 4 on the bottom because the only way to make it 1 is 4 over 4. 4/4 is a whole. 4 divided by 4 is 1 because fractions are just division problems. Okay? You don't have to draw the 1. I just sometimes do it because I feel like it's an easy way to remember. Now, after you do this, you're trying to find what 4/5 is equivalent to what. If I multiply, you're going to go straight across the top. 4 times 4 is 16. And you're going to go straight across the bottom. 5 times 4, and you would get 20. This means that 4/5 is equivalent to 16/20. Okay? So, if you know your basic multiplication facts, this is so easy for you. If you don't, that's where we got to start practicing all those basic facts. Okay, if I look at number 3, you could pick any number you wanted. So let's say this time I want to pick 3. If I put 3 on the top, I have to put 3 on the bottom. Take a second, solve this problem. So find 3/4 is equivalent to what if I multiply by my constant of 3? Okay, hopefully you found it. I'm trying to make this not blurry. I'm having a good day. Okay, if I multiply by 3, hopefully you saw that 3 times 3, you're going to go straight across the top, is 9. And 4 times 3, you should get 12. Okay? It's so important to show your work with fractions, okay? Because if you do make a mistake in multiplication, I can see exactly where your mistake was. If you just put random numbers, I have no idea if you... I think the last one cut me off when I was recording it. So, if we were looking at number 4, all you would do is you would pick any number. I picked 5, for example. You could pick whatever you would like. And then you're going to multiply straight across the top. So 1 times 5, you would get 5, and 6 times 5, you get 30, meaning that 1/6 is equivalent to 5/30. You could pick any numbers you want on all of these. So we picked that one was given 2, we picked 4, 3, 5, you could pick 2 again, you could pick whatever you would like. It is showing you the basics of how to find an equivalent fraction. This is like the background information we need to know before we start searching for different ways to find certain equivalent fractions. You could take this and multiply by a bunch of different numbers. They're going to keep giving you more equivalent fractions. So that's just how we're kind of using the understanding of it. I hope that helped a little bit. If you would like, you can either pause this video and complete the rest of this page, or after we finish this whole video, you can go back and finish it, because we are going to actually flip back in our packet and look at page 3 real quick. Okay, so you can either pause it, finish these last 5 or 6, I think there are, and then come with us, or you can keep going with us, and then you can come back to us at the end. Alright, so some of mine are done. I recorded it, and it did not save. So we're going to look at the bottom part, and then you guys can do the top later. It's the same concept occurring. How we're going to look at these is this is using landmark fractions. So if you're not at page 3 yet, take a second, pause the video so you don't fall behind. But we are going to use landmark fractions. Landmark fractions are 0, 1, and we can also use a half. It's comparing numbers to numbers you're familiar with. So we're all familiar with 0, we're all familiar with 1, and we're going to start becoming familiar with a half. To do this, all we're going to do is fill in the number line. So we're looking at how many sections is this broken up into. This is very, very similar to when we used fraction strips. Using fraction strips is the exact same thing. This is just drawing it on a number line. So what we're going to do is you are going to look at, we're trying to find where this missing box is. We're trying to see, okay, we're on number 3 too. I'm kind of mixing it up since the beginning didn't record for me. So you're counting how many sections. If I look here, between 0 and 1, I have 1, 2 dashes. This is not in half, though. That's the main thing. It's not how many dashes, it's how many sections. So if I look at my first section, from 0 to my first dash, that's 1. Okay. If I look at my next dash to my next dash, that would be 2. It's showing up blurry on my side. Still is. No. And if I go from that dash to my 1, that would be 3. This means that there is 1, 2, 3 sections. That is going to total up into whatever, how many sections is going to be your denominator. So if I look at my first one, this is 0/3. That's the same thing as 0. My next one, my denominator would be 3, and I have, if I look here, I have used 1 piece. Okay? If I go here, my denominator is still 3, but now I have used 2 pieces. So it would be 2/3. And as we did before, if I go to this last one, 1 is the same thing as 3/3. The same number on the top and the bottom, because there are 3 pieces and my denominator is 3. So that is labeling a number line. I want you guys to take a second and try number 4. Okay? Count how many pieces. So let's start there. How many sections of this number line how many sections does this number line have? Hopefully you found that. If not, pause the video and keep working. That's fine. You would see there's 1, 2, 3, 4, 5, 6 sections. That means that my denominators are always going to be 6 out of 6. Now, I know you don't have to label all of these, but it's helpful at first to understand the concept of it. If I look here, that is 1, 6. That means my numerator would be a 1. If I look here, that would be 1, 2, 6. So it would be 2. You can go all the way across. If I want to look here, I could say that that is 5, 6. So 5 would go on top. It's just how we're breaking numbers apart. In the box, that's covering 1, 2, 3, 6, and you can keep going and fill in the rest. All we're doing is counting how many pieces in total is it broken up into. That's your denominator, your bottom number. How many pieces you have is your numerator or your top number. I hope that helped. Before you go watch the next video, maybe you want to finish page 3 and the rest of page 4. So you can do numbers 1, 2, and 5. That should not take you very long. And then the next video is going to go over some of the other problems where we're doing more of the math base. This is more the background knowledge. So I hope that helped. Once you're ready, click the next video. And we'll keep going.